Hi everyone, this is Saad Aslam. I hope you are all doing well. So today we are going to discuss 278 number LeetCode question, that is the first bad version. Okay, so let's first discuss the problem statement. So you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, and all the versions after a bad version are also bad, and suppose you have n versions 1 to n, and you have to find out the first bad version which causes all of the following ones to be bad. Suppose like you have 10th versions like 1 to 10, and you have to find the very first version. Suppose the defect started from the third version, so you have to find out how we can get to that third version. Okay, so you are given an API that is isBadVersion, and we have to pass on the version number, and it will automatically return whether this version is bad or not. So the finding out the version is bad or not is the responsibility of our API isBadVersion. So implement a function to find the first bad version. You should minimize the number of calls to the API. So this is the main thing, like we have to minimize the number of calls to the API. Okay, so in example 1 you can see there n is 5, like there n version, and the first bad version is 4. Okay, so let's try to understand this in our whiteboard section. So if before moving on, if you haven't subscribed to my YouTube channel, make sure to hit the bell icon and all of the YouTube stuff. So let's go to my whiteboard section. So here we are in our whiteboard section. Here you can see like we have an array of version numbers, and these version numbers are of the product. Okay, so 1 2 3 4 5, like first version, second version, third version, fourth and fifth version. And suppose the fourth version is the bad version. Okay, suppose like we have, let me just okay, to suppose we have an API like bad version API. Okay, like this is the API that will return whether it is a bad version or not. And suppose like 4 is the bad version, and what brute force approach will be something like we check first, like suppose we check this is not a bad version, so the number of calls to this is like, let's try to count the number of calls. So first this, so the number of calls to this API, like it is 1, and it is not a bad version. Now let's check the second. It is also not a bad version, so the number of API calls increases to 2, and now again to 3, so it is also not a bad version, so the number of API calls increases to 3, and now again move to the second, like fourth, as fourth is a bad version, it will return true, but our number of calls here you can see will be something like okay, for this, like for then our number of API calls is 4, and in any case, like the time complexity of this approach will be something like order of n, like it will check all the elements to find the bad version. Okay, so this is the approach we are going to use here. So we are going to use binary search to make this first bad version. So let's try to use the same example, like 1 2 3 4 and 5. So here you can see that all the versions are in the sorted order. Like suppose we have 1 2 3 4 5 versions, so they will be in sorted order, like first version, second version, third version. Okay, so we are going to make use of these steps. So first we have to initialize left, like left will be currently at this, and right will be at rightmost, so it is 5, and our mid is will be the left plus right divided by 2, so mid is 3. Okay, so currently our position is this. Okay, so let's make use of this. Okay, so first we will check, like left is right less than right, left is less than and equals to right. Yes, we have calculated the mid. Okay, and if is bad version at mid, so bad version at mid. So as 3 is not a bad version, it is the responsibility of the API to return if it is a bad version or not. So we are supposing in this example, like 4th is the bad version. Okay, so as 3 is not a bad version, so it will not it will ignore this part, and it will move to the else condition. Left is equals to mid plus 1. So what is mid? So mid is currently 3, so our left is currently 4. Okay, so here you can see like using the binary search, it has simply like ignored this part. Like we do not have to process the left half, we can simply ignore that. It means like if 3 is not a bad version, okay, like if 3 is not a bad version, it means like all the versions before it are also not bad. So in our situation, like all the if a version is bad, all the versions after it will be bad. If a version is not bad, it means all the versions before it are also not bad. Okay, so left is 4 and 5, so it will again go to the while condition. As left is less than and equals to less than right, so it will again move to the checking the midpoint. So mid is left plus right minus left, so right minus left will be something like right 1, and so left is, so currently right minus 1 by 2, so left. Okay, so our mid will remain the same. Oh sorry, 4 right will remain the same, and 4 plus 4, so mid is 4. Okay, and if mid is bad version, like if is bad version, so as we have discussed, like 4th, like this is 4th is the bad version, this, so mid is currently this, and as mid at 4 is the bad version, then it will now check the if condition, like it will go to this if condition. So right is equals to mid minus 1, so right is equals to mid minus 1. Okay, so right is equals to mid minus 1. Mid is currently 4 and right is now 3, and bad version, the variable our bad version is currently what is at mid, so at mid it is 4. Okay, so else condition will not work, then it will again go to this while condition. So while left is less than and equals to right, as right is less than left, so this loop will terminate, and after the loop terminate we are simply going to return this. Okay, so we are simply going to return the bad version. And what are the number of API calls? Here you can see we just needed 2 API calls. For the first, like we calculated this 3, for this 3, and for the second we calculated this. So in the previous brute force approach there were 4 API calls, but we have minimized this to only 2 API calls, and the time complexity of this will be something like O log of n. That is the case of a binary search. So I hope you have understand the approach of it. It is quite we have discussed in our previous discussions too. So now let's try to implement this in our coding section. So let's move to our implementation part. Okay, so here we are in our coding section. We will first try to implement this in Java, and after that we will quickly implement this in C++. So as discussed, we first initialize left, and left will be you can say 0, and our right pointer will be something like the nth version, and our mid is simply we are just declaring it mid, we will initialize it in our loop, and int bad version. This is the version. Okay, this is the value we are going to return if we found the first bad version. So currently we are initializing it with n. Okay, so while left is less than and equals to right. Okay, so this is the loop we are processing, and after that we will calculate the mid. Mid is equals to left plus right minus left divided by 2. Okay, if and divided by 2. Okay, if. So here you can see this is the bad version API. We do not need to implement this. It is all functionality already implemented. We just have to call this API. So this is very simple. Like we are simply calling this is bad version. Okay, and we are going to pass the mid. Okay, and if it is a bad version, we are going to mid -1. Okay, and our bad version will be something like mid. Okay, else, in the else part, otherwise we are going to increment left to mid +1. So left will be mid +1, and after the loop terminates, we are simply going to return the bad version. Okay, so let's check for any grammatical or syntax errors. Right is equals to mid -1, mid +1. Okay, so let's try to run this code if we aren't finding any issues here. Okay, the code has run successfully. Now let's try to submit this. Okay, the code has been submitted successfully. So this is the implementation of it in Java. This is the implementation in C++ is you can say equal to this. Like we do not need to change anything in our C++ because we aren't initializing any data structures, we aren't using anything. This is the simple like variables initialization. We can simply you can say copy this for like if you want to run this in C++ too. So we are simply copying and paste the same code in C++. Now let's try to submit. First run this code. Okay, so you can see the code has run successfully in C++ too. Now let's submit this. Okay, so you can see the code has been submitted successfully. So the implementation is same in Java and C++ in this example. So I hope you have understand the approach, the implementation of it in Java and C++. If you have any questions, queries, you can let me know in comments. You can reach me out on LinkedIn. I have a complete series on this problem solving questions. You can go and check out my channel, and you can reach me out on LinkedIn anytime. So see you in the next video. Bye bye.